Welcome to Graverload. Now, Microsoft has announced work graphs, and hopefully, this is going to help improve gaming in the future and maybe even more in the near term. But my reading through and trying to get down to the details of this is that, they're trying to help, improve GPU driven render techniques. Like it says here, let me switch over to the right slide here, or the right screen. But you're going to have, improved, resource management on these GPUs. Instead of having maybe the CPU wait or maybe the CPU taking too long in a calculation, we're going to, in this work graph stuff, be able to kind of push that offload stuff to the GPU side. Now, AMD and Nvidia were, of course, on here. You can see that there had some work graph specs starting now on both the Nvidia and AMD GPUs. I'm sure Intel will be on here at some point. I hope. But let's jump over to what AMD was talking about here. Now, AMD went through some of this stuff at GDC 2024, as you can see in the summary. But what's kind of interesting, and there's a video here if you want to watch that, is that there were some stats in this demo. There was 6,600 draw calls per frame, 13 million triangles per frame, 200,000 work items passing through the graph, 37 nodes and 9 draw nodes. And so here is the difference. So lower is better in this. This is on the 7900 XTX in this execution, and execute indirect, which I don't remember if they had it. I think they had it described in here someplace where the execute indirect was basically not as a fiction, but it's kind of like how it's done now, if I recall correctly. I thought they had it in here, but I could be missing it, of course. But anyways, let's get back to it. So you're seeing where this is actually after like kind of like the first pass, where there's still work to be done. So this could even be a better scenario on the work graphs side. Now, graphs are kind of dealing to, I think Nvidia gets into it. This is Nvidia's technical blog, and they get into it a little bit, where the work graphs is another, they were excited, but the work graphs are kind of your, uh, here it is. The post includes high-level concept of work graphs, of structural, the launch modes, and data flow. No, maybe it was a little bit later. I've read through this. I don't remember where everything was in definition. Here it is. The term graph in the name holds up well in this definition. Um, the collection of nodes connected by edges in the work graph nodes performs task work and then passes the data to other nodes across the graph edges. So hopefully that makes some sense to you. If not, just think of it this way. It's, trying to make the GPU more efficient, or passing off the data to make the whole engine and everything else work more efficient, trying to more parallelize it. If we get down here to some of the um, this functionality side, but some of the GPU timeline, you'll see that in here in this figure, it illustrates the workload that are executed in each case. On the far left is a 2 dispatch call separated by a resource barrier. Each represents how the producer thread group in green and the consumer thread in blue. On the right, the same workload runs with work graphs. Notice how there isn't a barrier there in the dispatch side, or the dispatch barrier dispatch. So you can kind of push that GPU timeline a little bit closer without having that barrier in between. And I'm hoping that in all of this, I can't remember if there was another thing I wanted to show in here or not, but I'm really hoping that this all of a sudden starts, flowing through and start being used, and we start seeing some of these techniques, or some of these areas where we can start putting more, processing power of the GPU to work, some of the better scheduling. If you haven't seen the Gamers Nexus stuff with Intel's Tom. Oh, I'm forgetting your last name, Tom. I do apologize, but he was at Nvidia. He does some great technical stuff, and Gamers Nexus has done a really good job with him in their videos and on some of the GPU techniques with oh, proc, not I'm forgetting the name of it right now, but in there, in Nate Gamers Nexus, they've also done some of the scheduling stuff and worked on how that is working, how to make sure that from display time to execution and or display time with execution and everything else, how that graphics pipeline works. So I'd highly recommend you go check that out. Listen to there's some longer videos, but they're really good. Now with this WorkGraphs API, you know, hopefully this is going to, like it says here, solve some problems that we have today and enable new creative ideas. And I think is just another stepping stone in getting to another realm of, hey, we have to fix this. We have to work around another bottleneck or another thing where we can make more efficient. And as we progress down this path, I hope that I can kind of see this happening where AI is going to get involved to help us be very ability to help schedule and help figure out different workflows that could be more efficient on the GPU side. At least that's what I'm seeing where AI can be inserted into this and help us out as developers and as gamers, right? Because games are going to be better looking and everything else, have more work to do, that we can then get more frames per second, everything else. I can kind of see where this is going, and I hope that, you know, with, you know, Nvidia, AMD here, DirectX 12, as who knows, probably going to be DirectX 13, 14 or at some point with even more of this stuff involved, that we kind of see where these you know, graphs and calls and everything else will get more efficient, you know, through schedulers and everything else we have, but with different, you know, creations or like this work graph stuff to be able to make sure that we're getting better results on the back end. So I do want to take a quick moment to just talk about this. I think it was kind of interesting. I'm not, if you want me to dive into the details, I can. It would take me a lot more studying. I don't develop games, so I'm not into there. I do work on 3D stuff, so I will understand that part of it. But if you want that, leave a comment. I might dive in if enough people want it. But I wanted to say, like, in general, I think that this is going to be good for games moving forward. I hope that with you know, Nvidia doing some, you know, giving us some results of this, Nvidia hopefully do the same. Hopefully this will work its way in games. Like they said, there was some games that already have this. I think that was on DirectX Blair with Unreal Engine 5. They've been working on stuff like this, but if we can start moving this, you know, into engines and everything else and getting this on our games, I think a lot of people are going to be very, very pleased about it and in the rendering and playing the games. You know, anyone more frames per second, more performance, higher quality of games, we're all for it. So let me know what your thoughts are on work graphs, what you hope to see in the future of this. You know, this is just some more efficiency back end stuff, but in the kind of need the back end stuff to make the visualizations on the screen work. So with that, let me know what your comments are in the comments below. And thank you so much for helping support Gravity and helping this channel grow. I really do appreciate it. And until next time, God bless.